Overwatering and underwatering are two scenarios actually addressing the water conservation, which is one of the major global challenges. To maintain sustainability, a conscious and inclusive human effort is needed on increasing the graph of green growth. Hello everyone, we are Team AP062 from Ajigate, New Jersey, India. Our project Green Globe is a customized and intelligent watering system for horticulture. Overwatering is a severe case, as it is addressing two of the major global challenges. When you overwater the plant eventually dies. And when it is happening on a large scale, it directly affects the climate change and also affecting the water conservation. When you underwater the plant doesn't get required amount of water to grow efficiently. So underwatering the plant comes into an indirect active reason on climate change. Project Green Globe delivers the essential requirement of growing plants effectively and efficiently by regulating the overwatering and underwatering. The outcome also addresses to saving water while watering the plant at houses and other areas. Our main goal of this project is initiating the idea of connecting the edge technology for conservation of natural resources and addressing the global challenges.
The board comes with high-speed DDR3 memory and Ethernet networking. Basically, the D10 Nano development board consists of two parts, the FPGA part and the hard processor system HPS part. Since the cloud unit and internet plays a key role in our project, we chosen to use the HPS part, which is having a 800 MHz dual-core ARM Cortex-A9 processor with 1GB DDR3 SDRAM, one Ethernet RJ45 port, USB OTG port, USB micro AB connector, micro SD card socket, accelerometer, UART to USB, USB to mini B connector, reset buttons, and LTC 2x7 expansion header. The primary control unit has an additionally attached RFS Wi-Fi module, which consists of 2x20 GPIO interface pins, UART to USB, 2x6 TMD header, temperature humidity sensor, 9-axis sensor with accelerometer, magnetometer, and gyroscope. The secondary control unit is basically a ESP32 Wi-Fi module and a microcontroller. The secondary control unit actually takes the instruction signals from the primary control unit through the cloud unit and perform actuation. Here we are using Volt IoT Wi-Fi module, which comes with 5 digital GPIO pins and 1 analog GPIO pin, 5V, 3V and ground pins.
Let's look at our setup of the system. To make the usability of the system feasible, we decided to make the system to use it from anywhere. The primary control can be kept anywhere and still can perform the job. To access the internet via Ethernet, we set up this primary control unit inside our lab and left the secondary control unit at the field. The main program runs inside the board as daemon. Here I am running it to show the demonstration. We created an Azure IoT service to interface the RFS module through the cloud. We created device provisioning service for IoT Hub. We get the code template from the Azure GitHub page and modified the code to push the ambient temperature and humidity value to the database along with Azure IoT Edge. For your understanding, I bought the secondary control unit from the field and replaced the solenoid valve which flows the water to the plants with an LED. Here, when the water supply is needed, the LED will glow. There are various kind of garden implementation methods according to the fields and plants in it. We worked on the implementation aspect to make it flexible to implement for any kind of method. We designed the system and divided into implementation in 3 categories, making it suitable for any kind of garden crop plants. So one is pot level implementation. It is made for both indoor and outdoor pots. A soil moisture sensor is placed in the pot and is interfaced with plant monitoring unit. The value of soil moisture sensor is taken regularly. If it is in an indoor pot, the soil moisture sensor value and the humidity value are compared to deliver the water. If the pot is outside, the soil moisture value and the temperature values are taken to compute the water delivery schedule. The second is crop level implementation. If it is a crop, there is only one kind of plant but in more number. So the plant botanical data of plant is defined in the program. The program takes these values every time and deliver the water to the plants using the previously set algorithm. Third level is garden level implementation. The same happens with garden level implementation also. The difference between crop and garden is there are more than one kind of plant in garden. So we are taking the total number of plants and based on that density, the water is delivered by following the flow of algorithm. Functional description. The primary control unit is the central controlling part and connected to every other units mentioned. The code or the program which runs in the primary control unit fetches the APIs for weather condition and retrieves the ambient temperature value from the RFS module. The data is constantly taken for every 10 to 15 minutes. The dew point, clouds condition, precipitation summary, real field temperature, apparent temperature, relative humidity and pressure are taken from the Azure Maps weather conditions API in the order to perform rainfall detection. The previous and the present values of temperature are taken to predict the temperature forecast using linear regressions. The collected temperature values are taken to perform Z-score analysis. The Z-score analysis is basically anomaly detection. The program creates boundary for the flow goes to schedule the timing to deliver the water to plants accordingly. It is defined in the code previously that the amount of water required for plants. The date and month is taken to find the current season. If it is a hot season with high temperature like summer, the water amount is divided into number of times in order to avoid the water evaporation and deliver the plant required water. All these values are pushed into cloud storage point using internet. Meanwhile, the secondary control unit checks for the instruction signal in the database. It fetches the schedule timing and perform actuation at the time. It turns on the motor or water supply according to the runtime calculated.